Okay, welcome back to part 2 of solving equations involving gravitational potential energy, kinetic energy, and mechanical energy. We stopped at question number 8, which states which has more kinetic energy, a 3 kilogram mass moving at a velocity of 2 meters per second, or a 2 kilogram mass moving at 3 meters per second. So essentially this question is really 2 questions in one. So let's just kind of divide our workspace and write down our formula. Kinetic energy is equivalent to 1/2 mass velocity squared. And I'm going to write the same thing over here. So I want to look at the first part of this. We have a 3 kilogram mass moving at a velocity of 2 meters per second. So working this out, we're going to rewrite this as kinetic energy is equivalent to 0.5 times the mass, which is 3 kilograms. And my velocity is 2 meters per second. And I'm going to write that twice because, as you can see from the formula, it is squared. Setting up the second part of the equation down here, a 2 kilogram mass moving at 3 meters per second. So again, just simply rewrite the formula, exchanging the variables for numbers as we know them, 2 kilograms. And then my velocity is 3 meters per second. So now I can begin to solve and I can compare and see which one of these is going to be greater. So here, I have 0.5 times 3 times 2 times 2. So work that out in your calculator. Go ahead and pause the video and then come back and we will look at the solution. So looking at the first one, we have 0.5 times 3 times 2 times 2, and that's going to give me 6 joules. Okay, looking at the second example over here, the second part of this problem, we're going to have 0.5 times 2 times 3 times 3, and that gives us 9 joules. So it looks like the second example here, or the second part of this question, is going to be the highest velocity. Now, one thing I want to remind you of is to always make sure that before you begin any of the solving of your problems, that you first want to make sure that everything's in SI units, and if it is not, you want to put it in SI units through conversion. And that goes for mass as well as velocity. Okay, so let's look at another example. Number 9. Go ahead and take a minute to read this, pause the video, attempt to solve it on your own, and then we will look at the solution. Okay, so it says, what is the mass of an object that has 100 joules of kinetic energy and is moving at 5 meters per second? So this was going to be kind of tricky because we're going to have to work in a different order. Let's start, as always, by writing down our formula. Kinetic energy is 1/2 mass velocity squared. Now, it does tell us some of the quantities of the variables over here. We know that kinetic energy is actually going to be equivalent to 100 joules. And we know what our velocity is going to be. So it's going to be 100 joules equals 1/2 mass, and then velocity squared is going to be 5 meters per second times 5 meters per second. So let's begin by going ahead and simplifying everything and making it easier to read and interpret. So I know that 5 times 5 is going to be 25. And I'm going to have 1/2 mass times 25. Okay? And that's going to equal 100 joules. Alright, so if I want to get rid of this 1/2, I have to multiply both sides by 2. When I do that, I'm going to get 25m, and 100 times 2 is going to be 200 joules. Okay? So how could I isolate and find out exactly how much my mass is? What would I have to do there? I would have to divide by 25. So when I divide by 25, those cancel out, and I'm left with 200 over 25. If you put that into your calculator, you see that equals 8. And because we're talking about mass and everything else is in SI units, the unit is kilograms. So 8 kilograms would be your answer there. All right, next, let's look at another one. Number 10, what is the mass? So another similar problem. What is the mass of an object that has 32 joules of kinetic energy when moving at 2 meters per second? Take a moment to look at that one, and then we will examine the solution together. Okay, write down your formula first to begin. Okay, we do know what the energy is. The energy is 32 joules. Remember that energy is always measured in joules. Okay, and then it tells us the velocity. We're trying to find the mass. So we're going to say 0.5, okay, times mass, times 2 meters per second, and that's in SI units, times 2 meters per second. So let's go ahead and let's simplify. We're going to get 2 times 2 is 4. 4 times a half is going to be 2. So 2 times the mass. So again, that's 2 times 2 is 4. 4 times a half, or 4 divided by 2, or 4 times 0.5 will give me 2. So 32 joules of energy is going to equal 2 times the mass. And again, all of my units are in SI units. I have joules, I have meters per second. So when I do the math, then I don't have to do any conversion. My answer will be in kilograms. So we're going to divide both sides by 2. And then we get mass equals 16 kilograms. And that is your final answer for number 10. All right, moving right along, number 11 on your work. We're looking for velocity. So this one's a little bit more challenging. And the reason is, if you look at our formula, you can see the velocity is actually squared. Okay, so it says a 6 kilogram object, I guess, has kinetic energy of 75 joules. What is its velocity? So here, we know that the mass is going to be 6 kilograms. We're trying to find velocity, and we're going to multiply that by 0.5 because it's the same thing as 1/2. And it tells us the amount of energy, which is 75 joules. Okay, so let's go ahead and let's simplify. 0.5 times 6 is going to be 3, so we're going to have 3 velocity squared equals 75. This is quite simple. We're just going to go ahead and we're going to divide both sides by 3. When we do, that cancels out, and I get velocity squared is equal to 75 over 3, which is 25. Now, how do I get this to say v equals something? What do I have to do to unsquare that? What's the opposite of squaring something? You might realize that what I need to do right here is to find the square root of both. When I do that, I get v equals the square root of 5, which is 5. And again, because everything else was in SI units, I had joules and I had kilograms, this will be in SI units, so that will be 5 meters per second for my answer. Alright, number 12. An 8 kilogram mass has a kinetic energy of 144 joules. What is its velocity? Another situation where we have to find velocity. So you can assume we're going to solve this in pretty much the same way. Let's just go ahead and set it up, replacing the variables with the numbers that we know. Alright, so we know that we have 144 joules. That's going to equal 0.5. Remember, this is 4 things you're actually multiplying together. So 4 things. So 0.5. Then I have the mass, which is 8 kilograms. And then I'm going to have velocity times velocity, but it hasn't told us a quantity for those, so I'll simply put down velocity squared. All right, so take a minute to see if you can simplify and solve that, and then we'll talk about the solution. Okay, coming back, let's just simplify this. 0.5 or 1/2 times 8 is going to be 4. 4 times velocity squared is going to be 4 velocity squared is equivalent to 144. I'm going to write this down without the unit, and I'm doing that because I believe that's simpler and easier for you to look at and less confusing. First thing, make sure that everything's in SI units. If it's not, establish those SI units, then solve. I need to simplify this. I'm going to divide both sides by 4, and then I'm going to rewrite the equation. Those cancel out. 144 divided by 4 is going to give you exactly 36. So we have 36 equals velocity squared. To find the answer here, I have to do the opposite of squaring, so I can basically turn velocity squared into velocity. I do that by finding the square root of both. Now this is pretty easy. The square root of 36 is 6. I've always known that 6 times 6 is 36 ever since I was a small child. You have too, so that's an easy one to solve. And again, this is going to be in meters per second. It is already in SI units for the answer because everything else is in SI units before we begin, as it should be. So again, 6 meters per second is our answer for velocity. Number 13. Another situation when we have two things we're going to compare. I'm going to go ahead and free up some space on my board here. Alright, now I'm going to draw a line down the middle so I can compare the two. Alright, so which has more energy? A 2 kilogram mass at 10 meters per second or a 2 kilogram mass 5 meters above the ground? So I don't know if you realize this or not, but we're actually looking at kinetic energy on one part of this and gravitational potential energy on the other part. I'm going to write down my formulas. Kinetic energy is equivalent to 1/2 mass velocity squared. Gravitational potential energy is equivalent to weight times height. But for this example, I'm going to change that formula. I'm going to use my other formula for that. I'm going to use GPE equals mgh. Just so you remember, and let me clarify, mass, gravity, height. So that's the one I'm going to use for this. And the reason I'm going to do that is because, as you can see, it does not give us the newtons of force for weight. It gives us the physical property of mass. So I'm going to use that instead. Looking at the first part of this, 2 kilograms at 10 meters per second. Pretty fast, but let's look at what it is. So we're going to have kinetic energy. Let me rewrite that. Kinetic energy equals 0.5 times 2 kilograms, and I could write this without units if I wanted to, times 10 times 10. Over here, I'm going to have GPE equals 2 kilograms. And I'm going to go ahead, I could use 9.8, but to keep things simple, I just want to go ahead and change that to 10. Because I'm going to do that, I need to change my equal sign here because that's not precise. So times 10. And then the height, it says that my height is 5 meters. Alright, let's go ahead, let's simplify and solve. 10 times 10 is 100. 100 times 2 is 200. 200 times 0.5 is 100. Mental math. So we have 100 joules for kinetic energy. Over here, 2 times 10 is 20. 20 times 5 is 100. Again, 2 times 10 is 20. 20 times 5 is 100. So interesting scenario here. We have a couple of different ways we could answer this. We could say that it's about the same, but if you remember, the actual measurement here for the acceleration due to gravity is 9.8 meters per second squared, which means I actually rounded this up a little bit. So if you look at the precise numbers, what you're going to find is that precisely if I change that to 9.8, I would get something slightly less than 100. Just to show you what I would have to multiply 2 times 9.8 times 5, and that would give me 98 joules. So the actual precise number is 98 joules. 100 joules is a close approximation. So technically speaking, the first part, or the kinetic energy, would be highest. Number 14, another situation we have two situations that we're comparing to each other. Which has more energy, a 20 kilogram mass moving at 9 meters per second, or a 4 kilogram mass 25 meters above the floor? Let me erase what I have here. And I already have my formulas written down, so go ahead and try to solve that on your own. Go ahead and pause the video, come back and look at your solution. Okay, setting this up. My mass is 20 kilograms. Let me rewrite that 1/2 as 0.5 just to make things easier. My mass is 20 kilograms. My velocity is 9 meters per second. Writing that twice because remember, when you solve for kinetic energy, you have 4 things you're multiplying together. 0.5, mass, velocity, velocity. So this is my setup for the first part of this. My second part, I'm going to use MGH, mass, gravity, height. And again, I'm going to go ahead, I'm going to use 10 instead of 9.8 because it's much easier. So GPE is equivalent to 4 kilograms times 10 meters per second. And then times is height off the floor, which is 25 meters. Let's go ahead and let's solve that. Just so you know, I'm going to do this a different way. 4 times 25, I know that that is going to be 100. 100 times 10. My GPE, 100 times 10 is 1,000. Just using mental math here. Sometimes you can do that, sometimes you can't. It depends on what numbers you have. All right, looking over at the first example. All right, so I have 9 times 9, that's 81. 0.5 times 10, that's going to be 10. 10 times 81, 810. And again, make sure you express everything in units of joules if you are referring to energy. So here I have about 1,000. Again, this is not precise, so make sure that you indicate that. And always remember, if you're estimating here, if you're going to round this up to 10, that it's always going to be slightly higher than what it would be if you use a precise measurement of 9.8. Okay? So here you can see in this situation, the second part of this part is going to be more than the first. So you would say that the 4 kilogram mass, that's 25 meters above the floor, actually has more energy. All right, let's look at number 15, which is my favorite. I love this question. All right, Kyle throws a 2 kilogram object into the air at 7 meters per second. How high will the ball go? Now, the question here is this a kinetic energy problem or is this a gravitational potential energy problem? And the answer is, it's actually both. You have to find one to find the other. So let's do that. I'm going to leave both of my formulas on the board because I'm going to use both of them. So the first part, looking at the mass of the object and how fast it's moving. So I'm going to say kinetic energy is equal to 0.5 times the mass, which is 2 kilograms, times velocity, times velocity. So let me go ahead and solve that part of the problem, okay? So 7 times 7 is 49. 1/2 times 2 is 1. 1 times 49 is 49. So my kinetic energy is 49 joules. Now, the only formula that deals with height is the gravitational potential energy. And I'm going to go ahead and rely on the second form of this problem because it doesn't really refer to weight, and I don't know my weight. So, looking at this formula, GPE equals mass, gravity, height. Well, I know what my mass is. I know my mass is 2 kilograms. So I'll write down 2 kilograms. I know that the acceleration due to gravity is 9.8 meters per second squared. I'm trying to find height. I don't know that. Now, you can't solve an equation if you are missing 2 different variables. So I need to know what this is. Well, here's the thing. Because of the law of conservation of energy, all the energy for the gravitational potential energy is going to come from me throwing it up into the air. So this number actually becomes my value for potential energy. Now I can solve. So go ahead and put this into your calculator and solve. So let's start out. 2 times 9.8. That's going to give me 19.6 times height is equivalent to 49. Now, if I take 49 and this side, divide both of those by 19.6, I'll be able to isolate height, and again, I will know that that's going to be in meters. So those cancel out. 49 divided by 19.6 gives me 2.5 for meters. Now, you might think that that question was difficult. You might think that it was simple and easy. The point is, for some of these questions, you're going to have to think, reason, and use your logic. It might take you a little bit of time, but as you can see, it is definitely possible. Thank you for watching, and I wish you the best of luck on your quiz.